I'm going to run an A/B test where I know, with certainty, that both variants are identical. Same page, same button, same everything. I've simply labeled half the visitors A and half of them B at random. There's no effect to find because I didn't put one there. Now I'll check for a significant result every day for 2 weeks and stop as soon as I find one. Doing that, I declare a winner about 30% of the time. Not 5, 30. That's the peaking problem, and it is, I think, the single most common way real experiments produce false results in industry. Today, why checking your test repeatedly breaks it, how badly, what to do instead, and the wider issue of why running lots of tests guarantees you'll find things that aren't there. First, the honest version of how an A/B test is supposed to work. You decide your sample size in advance, using exactly the power analysis from last episode. You run until you hit it. Then you look once and you make a decision. That procedure genuinely has a 5% false positive rate, which is what the 5% threshold promises. The promise is real. It's just conditional on you following the procedure. But nobody does that. There's a dashboard. It updates live. You check on Tuesday, nothing. Wednesday, nothing. Thursday, P equals 0.04, and you stop and ship it. That feels responsible. You are monitoring your experiment. But it isn't one test anymore. It's 14 tests, and you kept going until one of them passed. Each look gets its own roll of the dice, and you only needed one to come up. Let's simulate it exactly. Both groups get the same true conversion rate, 5%, so any difference is pure noise. We add 100 visitors to each group per day for 14 days. And each day, we run the test and record whether P has dropped below 0.05 at any point so far. The critical line is the stopping rule. Look at the difference between these two conditions. Testing once at the end asks whether the final p-value is significant. Peaking asks whether any daily p-value was significant. That's an any versus a single, and that one word is the entire bug. You've turned one question into 14 chances to get a yes. Run it 10,000 times. Testing once at the end, false positive rate 5.1%, exactly as promised. Peaking daily for 14 days, 30.4%. Same data, same test, same threshold. The only thing that changed was how often we looked, and the error rate went up 6-fold. Here's why visually. This is the running difference between the two groups over time in one simulated experiment where the truth is 0. It wanders. Early on, with small samples, it wanders a lot. The dashed lines are the significance boundaries. You can see the line cross a boundary early, then come back because, of course, it does. There's nothing there. If you'd stopped at that crossing, you'd have shipped a result that was pure noise. And it gets worse the more often you look. Testing once, 5%. Checking weekly for a month, about 12%. Daily for 2 weeks, 30%. Continuously on a live dashboard, and the false positive rate tends toward 100%. Watch a null experiment forever, and you're guaranteed to see a significant result eventually. Guaranteed. It's just a random walk crossing a fixed line. So for fixes, in order of how much I'd recommend them, fix your sample size in advance and genuinely don't look. If you must monitor, use sequential testing, which sets stricter boundaries early precisely to pay for the extra looks. Use a Bayesian approach, where continuous monitoring is coherent by construction. Or, at minimum, run for whole business cycles, because a test that ends on a Thursday and started on a Monday has a weekday bias baked into it. The wider caveat is that peaking is just one instance of multiple comparisons. If you test 20 metrics, you'd expect one to come back significant by chance. If you segment your results by country and device and browser until something pops, that's the same error wearing a different costume. The rule is simple to say and hard to follow. Decide what you're testing before you look, and count every comparison you make, including the ones you don't report. One sentence. Every extra look at your experiment is another chance for noise to cross the line, and the 5% guarantee only holds if you look once. Next episode, we stop testing differences and start predicting numbers. We'll fit a line to data from scratch, and then I'll show you 4 datasets that share the same mean, the same variance, and the same correlation, and look nothing like each other.